Good afternoon. My name is Mitch Robertson. I'm the Director of Enterprise Systems at Curo Financial. I've been talking with a lot of people that seem to have questions on why I like to use wired data to troubleshoot problems and why I like to have the visibility into what's actually happening on the wire. Because of that, I've been asked a couple times about giving some explanations for it and getting into some details about it. So I wanted to start this mini series and really kind of talk about why wire data. Why is it important to us? Why do we want to use it? Why do companies need to be looking at the idea of getting information and intelligence off of what's passing across the wire? So why is this wire data so important to monitor? That's part of what this whole series is going to break down, why it's important to monitor it, your data as it flows over the wire, get into some technical details of the benefits, as well as some of the tips and tricks throughout my time monitoring data on the wire. A lot of people, when you start talking about data on the wire, they start to get concerned that they're talking about spending time in packets. And today, we don't have to do that as much as we used to. There's some really cool tools out there that do great analytics for you and provide an enormous amount of information for large scale environments. So I really wanted to start showing some of that to you and how I tend to use it and places where I've seen benefits. For us to do that, we're going to start talking about the L7 protocol and the value of knowing and understanding those L7 protocols. We'll start to break down the value of each of them, and then we'll spend some time going through how to monitor them and what to look for and some of the caveats related to each of them. We're going to first start off with protocol, or with the protocol DNS. This is, my belief, this is one of the most important protocols out there, but it's often a set it and forget it protocol. It's the basis for everything. Pretty much anything on the internet now communicates via DNS. Obviously, or not via DNS, but it has to resolve its name. Whatever name is typed in the browser, whatever the application is querying to, has to get that name somehow, some way. And it does that through DNS in most cases. And I'll have another video that'll come up that's a little bit longer that'll go into name resolution in a little bit more detail. But this is kind of a short video just to get an introduction to this series that I'm trying to get into. It's the first step of most systems to figure out what to communicate. If you think about it, when I type www.google.com in my browser, that's one of the first things that has to take place besides the code that happens on the local machine. But in order for me to communicate off of the machine, I've got to do a DNS request so I can get an IP of what I need to connect to. Oftentimes, it is a set it and forget it protocol. A lot of people set it up and they really don't pay attention to it anymore. It's interesting to me that the security teams are starting to pay attention to it way more than ever before. All the security documentation I've ever read talks about monitoring DNS. It's one of your first lines of defense. You can see a lot of really cool things if you are monitoring it. The bad thing is the applications people aren't paying attention to this. The applications, this is probably one of the most critical things to monitor in your environment. So there's a lot of things that happen that most people are unaware of and really haven't even thought about. They probably were taught or trained or read about it, but didn't put it together or how they could monitor it in a large scale environment. So I'm going to try to attempt to show this. We're going to begin by talking about a DNS packet. If you take a look, I've got a DNS packet for www.google.com and standard packet, standard query. We see the query go out, and the first thing up at the top is you see the transaction. We'll go into more detail around this as time presents, but we'll use this a lot. This transaction ID is kind of important. So there's the transaction ID that takes place. And again, I'll have some longer videos out that talk about this in more detail. But for right now, we're just going to talk about this query and response. The second thing you see is the response. You get a response back. It tells you it's an A record. It tells you the transaction ID, as well as the IP address that it gave in the response. So question here is does every response or answer have only one answer, or are there multiple answers? What other things in the response are important? What other things in the query might be an important amount of information? If you also take a look, we get some interesting things over here that we can tell about time, right? Time becomes important. Let's dig into it just a little bit more. As we take a look at the request, obviously you see the transaction ID, that's important. I'm going to keep reiterating on the transaction ID because I think it's very important to have that information or know where to get it at least. The query itself was for www.google.com, and it was an A record that it was querying for to begin with. The name was www.google.com, how long that record was, the label count, and it being a type A for A record. And so then it also gives you in Wireshark, they at least do some intelligence and say, hey, they saw the response also, and the response is in frame number 2. So we're going to look at frame number 2 and see how that goes. Frame number 2, again, we have that same transaction ID that is used. We also have some other information, and we actually had this on both. We had the destination and source port. The destination port, where it's going to, becomes important, and again, I'll cover that somewhere else at some point in time because there's some other cool things that if you know about that destination port that you can do. It's really pretty neat in my opinion. Really fascinating that they thought of all this stuff happening on the wire. I think it's really kind of cool. So then down below you have the query itself, so it repeats the query is in the packet just to tell you what was being queried, and then the answer itself has all the additional information about the answer, the IP address, that sort of thing. And Wireshark, cool thing is you actually have the time in seconds, right? How long did it take to get that response back? Pretty cool stuff. Also gives you this cool thing called the time to live record. And again, that'll be something we'll talk about more in detail as we get into this series, as we go through it. I will be posting a longer video that talks about all of this to some extent, but I'm going to keep doing these little tidbit videos to throw them out and see what people think. What other cool things are there in this packet that you can take and learn about your environment if you ever took some time and dug into the packets? Think about it. Maybe even ask some questions if you have. So what's the value of the info? If we have all that info, and if we actually account for that info appropriately to analyze it, we can get things like DNS timeouts, DNS errors, DNS misconfigurations off the wire, DNS tunneling, DNS requests, DNS responses, DNS server performance, DNS record types. Interesting thing about this response, if you go back, if you take a look at that record that I had before, it showed the response. A lot of people set up their SIMs and they only record the response because they see the request in the response. Problem is, that's not always the best thing to do because requests that don't get a response also tell you a lot of information. So there's things that you really want to take a look at. And so how do I monitor that at scale? If you take a look at this is from RevealX, this is from ExtraHop. ExtraHop has a solution called RevealX, which I think is extremely powerful. It gives me this great dashboard that I can look at on a regular basis and see quite a few things. I can tell how many response errors I have. I can tell the top DNS errors by query, so it tells me what things are querying that are not getting a proper response back. Important to know. Or getting an error back. There's a difference between not getting a response and getting an error because most responses should come up with an error. You get the request timeouts. So those are the things that a request has come through and has not finished all the way through. And so, or the server never responds to those. That's an actual timeout, and that's a problem. So again, good information. How many requests I've had, how many responses I've had, those are all great details. Server throughput, how big is all of this? How thick is all this traffic going through? What if there's DNS tunneling going on? Can I spot it through this? Absolutely. What's my biggest DNS response or query response in this case? And then types of records that are queried. All these things are details that I can get very, very quickly for my environment live as it's going through if you have this RevealX appliance in place. Really does a good job of giving you that quick, deep analytics that I can dig into. And I'm going to spend some time over the next couple of weeks posting little videos that go into details about some of these specific graphs as I have time. So I appreciate your time. Hope you enjoyed this video. Please reach out and ask questions. We'll see where it goes. Thanks.